In this lesson, we will be learning about differentiation. So if I'm given a function y equals f of x and I want to derive that function, the derivative of y equals f of x is the measure of the rate at which the value y changes with respect to the change of the variable x. So the value y of my function will change depending on the amount that x changes by. So here y depends on x. Now, if I'm given this curve and I want to find the gradient at point B. So normally we draw a tangent line at point B and I pick 2 points on the tangent line. Then I use the gradient formula y2 minus y1 over x2 minus x1 to find the gradient at point B. Now, another way is to derive the function of the curve, of this curve. So if I find the derivative of this curve and substitute a certain value of x, the answer will be the gradient of the curve at that certain point. So the derivative of the function f of x is the slope of the tangent line to the curve. So instead of using the formula, I can derive the function and then substitute a certain value of x to find the gradient at that certain point. So if I'm given f of x equals x to the power of n, where n belongs to r, and r here is all real numbers. So f prime of x, or dy over dx, which is the derivative of the function f of x, is n times x to the power of n minus 1. So n goes down and becomes the coefficient of x, and I subtract 1 from the power n. The answer will be f prime of x, or dy over dx. So in this example, I have to find the derivative of the following functions. So in part A, I have to derive x cubed. So to derive x cubed, the 3 goes down, so it becomes 3x to the power of 3 minus 1, because I have to subtract 1 from the power, so the answer becomes 3x squared. In part B, I have to derive 4x. So the power of x here is 1. So the 1 goes down, so it becomes 1 times 4 times x to the power of 1 minus 1. So the answer is 4x to the power of 0. So x to the power of 0 is 1 according to the rules of indices. So the answer is 4 times 1, which is 4. In the last part, I have 3x squared minus 5x plus 6. So for the first term, the 2 goes down, so it becomes 2 times 3 times x to the power of 2 minus 1 minus. Now here the power of x is 1, so the 1 goes down, so it becomes minus 1 times 5 times x to the power of 1 minus 1, and I have 6, and the derivative of any constant or any number is 0, so plus 0. So the answer becomes 6x minus 5x to the power of 0. So the answer is 6x minus 5. In example 2, it says find the gradient of the curve 5x squared minus 2x plus 2 at x equals 1. So to find the gradient, I need to derive the function 5x squared minus 2x plus 2. So f prime of x is equal to, so the 2 goes down, so it becomes 2 times 5 times x to the power of 2 minus 1 minus 1 times 2 to the power of x, or times x to the power of 1 minus 1 plus 0, because the derivative of 2 is always 0. So it becomes 10x minus 2 times x to the power of 0, and x to the power of 0 is 1, so the answer is 10x minus 2. So this is f prime of x. Now to find the gradient, I have to substitute x equals 1 into f prime of x. So f prime of 1 is equal to 10 times 1 minus 2, which is equal to 10 minus 2, and the answer is 8. So the gradient of the curve at x equals 1 is equal to 8.